Hello and welcome to Patrick's Models and Transport. So, I've reassembled the bogies and all the wiring of the Gè BB9240 SNCF rubber belt drive locomotive, but I've still not fitted the belts. Because I've not fitted the belts because before doing that I wanted to make sure that all the wiring was fitted correctly and that the pickups, which I cleaned and lubricated, that was the first job I did. Remember, the wheels were very oxidized, not really very oxidized, but the bogies were very dirty, and so to do a recap, the bogies, the wheels pick up the electricity, so all 4 wheel sets. And they transmit the electricity by means of the axle pins directly through into the axle boxes, onto the 2 sides of the bogie, which is the side elements are made of Zamac, which side elements are then transmit the electricity. Electricity is conducted directly by these screws, and we have these contact plates here, and by means of cables it's fed to the motor. Okay, so now we have current, we have power, and we're actually going to do a static test run, meaning just to test the motor. And here we go. I'm at very low speed. The motor is very reactive. So this is also a mechano controller. Mechano controllers have got very good low voltage speed. So I think this will be a really good slow mover. There you go, and practically it. If we look carefully, there's a slight wobble from this drive shaft because it was slightly bent, and I straightened it by hand. It's actually quite a soft metal, so you can straighten it by hand. I straightened it as much as possible, and there is, in my opinion, still a slight wobble. You can feel it when you put your finger on it. This one here is much more regular to the touch. This one is, but the motor has loads of torque. Lots of torque, this motor. Look at that. I'm putting my finger on it, but no effort at all. Continues turning. So I straightened this one here to the best of my capabilities, and it's okay anyway. But when it will be held down by the rubber bands, it'll be okay. It's better than what it was before. You can see that there's a slight. I might anyway take it off again and have a go at it and try and straighten it again, but quite a difficult thing to do. Anyway, apart from that, we can see that the motor runs very well, turning up the voltage. Let's go 25%. You see that it's jumping a bit here, but once you put the finger here, once this will be pulled down by the rubber bands, there won't be all this jumping. The one at the front's absolutely well balanced. This is slightly unbalanced. It's okay. I'm going to go up to 50%. 50%, this is a real pocket rocket. I'm curious to see how it's geared. Okay, 75%. I don't think we're going to be going at 75%. You can smell the brushes. But conductivity of the wheels on the bogies is fantastic. This is steel rail. This is not great stuff. Plus there are the fish plates as well. And just moving it along to simulate it moving. There's no bends on this test track, of course, but I'm pushing it up to maximum power. Full 12 volts, there we go. Turn round, down to 50. Let's go the other, they can go the other direction. bit of a tick over. A fantastic motor. And you can see that this is also a good occasion to test my couplings. So, as we saw in the previous videos, I decided to use some PVC, if I don't remember, but I think it's PVC. Let's see what it says here on this label. Oh, it says here PPS. No, silicone. It's a silicone rubber tube hose used for aquariums. In fact, yes, you can feel to the touch the silicone is not PVC, which is nice and flexible and guarantees a good snug fit. The problem was that it was a little 2mm internal diameter. It was a little bit too wide for the drive shaft and in particular for the motor shaft. But I widened the diameter by using two small sections of two small lengths of heat shrink insulation, which I then heat shrunk in position, and these are respectively 4mm on the motor shaft and whatever it takes. That'll be, it's under 4. You just stick it on and then cut it off with a cutter for the actual drive shaft. And you can see if I go and try and catch, I'm going to grab the drive shaft. There's no slippage. The coupling is very, very tight. So this replaces a brittle, decayed rubber coupling which was permanently fixed to the motor shaft, and then you would pull the drive shafts out of them to be able, to replace the belts on the bogies. So mentioning the bogies. So there's another problem. Right, now I've reassembled everything. Problem, it's not really a problem. I reassembled everything just to see that everything fits properly, that the motor runs, it picks up electricity from all 4 wheel sets, so everything's good. So in this sense, it's good to go. We have to fit the rubber bands. So let me go catch a rubber band to show you. Here they are. I bought 150 grams of 20mm diameter or 2cm diameter rubber bands, and these have to be fitted to the axles, the cylindrical axles, and then pulled up onto the drive shaft. So the best thing to do, you just pop the drive shaft out, fit these you have to open up the side of the bogie, put them on the axles, and then pull them up and just pop the drive shaft back in. That's why I didn't want something too tight, because this has to be able to be pulled in and out. And the only thing is that this is a very complicated system. So we think that Gè devised this rubber belt drive because they wanted to access the model train markets, because Gè made plastic toys, toy cars, dolls and the like. And in I think in the 50s and 60s, there was a late 50s, beginning of the 60s, I don't remember. I read the history on a French website. I'm going to look it up again, and when we do the final video with the test run and all the rest of it, I'll do all my homework, and we'll actually put that in the description box so you can go and do some extra reading. Anyway, they wanted to access the toy train market, so they made this very interesting model, which is very heavy, because this is very heavy. It rattles because the flanges are very big, and this is a defect of some of the old Lima straights. This is very old steel track on Lima straights, and wheels with big flanges touch here, no, where the sleepers are fitted. The problem, listen, if you go on the Jouef track, it doesn't happen. So drive track is silent. In fact, on the layout, I've eliminated nearly all the lengths of old Lima straights. I think there's something in a siding and one on a bend as well. There's a bend, so okay, this locomotive will be a bit noisy when it goes around the bend. Okay, it will drive me around the bend. Oh, that's a dreadful joke, isn't it? A pun. Okay, anyway, I'm not here to make dreadful jokes. So, to be able to put these back on, the belts, I'm going to have to take the bogies off, slacken one of the contacts, pull the side of the bogie out, put the rubber bands around the axles, then refit the bogie, screw the bogie back on, and because of course the bogie, to open a bogie, you have to slacken open to this screw here. You can see here, right, this is partially covered by the there you go, there's one of them. You can see a screw there, and the other screw at the front, which other screw at the front is also has a contact screwed onto it. So on the whole, this is a complicated system. And going back to what I was talking about with Gè before, I'm not following a plot in this video. I'm just chatting away, and that's my excuse for being repetitive. Anyway, the whole idea of belt drive for Gè was to reduce manufacturing costs, because making gears was expensive. They would have had to make plastic gears, meaning you have to have the molds to make the gears, etc., etc., or else maybe brass gears, even more expense. And to avoid making gears, they simplified the mechanism as much as possible. So large, very good torque 3-pole motor, metal. These are steel. This is mild steel by the look of it, because it tends to bend. Steel drive shafts, plastic, cylindrical plastic axle wheels, which also act as drive, and good quality brass wheels, because the wheels are brass, and this thing does pick up electricity, no problem at all now, huh? And the wheels weren't bad. If you look at the older videos when I cleaned the wheels were really not that bad, huh? And the Zamac, of course, to make the bogies. So that's that for the moment. So tomorrow we'll actually make a video of fitting the rubber bands to the axles, at least one of them. Yeah, I'll do one. I'll do one off camera. That way I can do all the swearing on my own. all the bad words, all the swearing, all the foul mouth will be off camera, and then we'll do a nice one on camera without the beeps. Okay. Right. And I hope you liked the video. If you've got, let me know what you think about this locomotive, and that's it. If you like the video, give it a like, subscribe to the channel, and of course click the notification bell. I'm just going to give this another buzz, and we'll call it a day. Wow, nice. A lot of work here. 25%. Can't wait to see it running around the layout. Cheerio, and see you next time. Ciao, ciao.